CQRS, or Command Query Responsibility Segregation, is an architectural pattern that separates the concerns of writing data and reading data into two distinct models. Command, responsible for writing operations that modify the application's state.
It's the single source of truth for data changes.
Query, it handles read operations to return data without altering the system's state.
It represents a query to request information from the application.
When working with different databases for storing and retrieving data, the application must be synchronized.
One possible solution is to implement CQRS with event sourcing, which stores the application state changes in a sequence of events.
But for this demo, we will apply an event-driven architecture style.
Welcome everyone! Today we will learn how to apply CQRS with event-driven architecture style, but also combining a clean architecture style using the MediatR pattern. So for this video, I will use the template that I created in the MediatR pattern video. You can check out my video, I'll put the link in the description below. It's based on a clean architecture style, which contains the core folder with the application and domain layers, the infrastructure layer with persistent layer to simulate a database connection, and API to perform HTTP requests. So the first step to apply CQRS is to divide responsibilities, to segregate queries and commands. So in the persistence layer, I will add two methods in the database service. One method to create data to get a list of users, and one method to create a new user, which will represent a command in the application. So the first method is to return a list of users, and we will define a private static read-only list of users to mock the users from any database and initialize with a fake user. The user entity contains the ID and the name, just two properties to keep it simple. It's located in the domain layer, so the ID and the name of this fake data or fake user, and the getUsers method will return the users. The second method is to add an user, a void method called addUser, which receives the name, and add an user to the list with the ID as an incremental ID by calling users.count +1 and the name defined by argument. So to use these two methods, we need to modify the contract for this database service in the interface located in the application layer. The first method is to get users, and the second signature is to add an user. We'll simulate two databases, one for reading data and one for writing data, but we will use the same database service to keep it simple. The idea is to publish an event when an user is created to update the reading database. So go to the application layer and modify this getUser handler to getUsers query handler to emphasize the use of CQRS, and the getUser request, let's modify to getUsers request, which has no properties and will return a getUser DTO. Okay, this getUsers query handler just returns data. It doesn't change the application state. This users property will be database service that get users with no arguments, or we will return a list of getUserDTO, but before that modified the getUserDTO to return a list from the iRequest handler interface and also from the iRequest interface. And I will use a select method to transform this list of user to a list of getUserDTO. So returned a new user with ID defined by the ID element of the user ID, and the name would be the name of the element. Okay, and transform this to list. So this handler uses the MediatR pattern, but also applying CQRS, in particular for querying data or querying users. Okay, now we will add the second handler to create a user. So in the application layer, add a new class called createUserCommand handler. Define the request for this handler, which will be createUserRequest that implements the iRequest interface and will return nothing and has a field that is the name of the user. And then in the handler, implement the iRequest handler interface that takes two types, the create user request and the response. There is no response at all. So just define the get user request and implement the interface. So this create user command handler will perform business logic to add a user in the writing database, but also publish an event to send a notification to the other side, the reading side, to update that database as well, to keep consistency between both databases. So to accomplish that, we will inject the iMediator interface in the constructor to publish a notification. So assign a field, and in the handle method we will call mediator.publish. But which object we need to publish? So in the application layer, let me add a folder called events, and in this folder we will add a class called createUserEvent, which will represent the model of the notification of the event, which will represent the event model. So to use this model, we need to implement the iNotification interface, and this event will contain the name of the user. Okay, and now in this create user command handler, we can publish this new event by calling the create user event, import the reference, and the name will be request that name. Okay, before that we will perform business logic locally to update the writing database, and then publish an event to update, to synchronize both read and write database, and finally return task that complete task. So the final step is to create the corresponding handler for this create user event handler, for this create user event model. So in the application layer, let me add a handler called create user event handler. It's a little bit different because it will implement the iNotification handler interface by defining the type, in this case the create user event model, implement the interface, and this handle method will simulate the synchronization of both databases. Okay, so in the constructor, I will inject the iDatabase service to add the user in the same database service class, in the same static list, just to keep it simple, but we will see the eventual consistency in action. So assign a field, and in the handle method, I will add a delay to see the eventual consistency problem at a delay of 5 seconds, and then call database service that add user, passing the name from the identification. Okay, now it's time to test the API. We've defined 3 handlers: one handler for querying users, one handler for creating a user using the CQRS pattern, and applying the event-driven architecture style by publishing events to synchronize different databases. So now go to the API, the user controller, and add 2 endpoints. The first endpoint is to get users. We just create a new instance of the get users request model. The second endpoint is to add an user by defining the name as an argument, and call mediator.send, and creating a new create user request model and passing the associated name. Now it's time to test the API. From the application, get users. As you can see, we have one single user, the fake user that we created in the database service and now add an user called Paul, execute it, but execute the get. As you can see, we just have the same user. Why? Because we've added a delay of 5 seconds to add the second user. Execute again, and as you can see, we have the latest version of the users, and we saw the eventual consistency in action.
What are the benefits of CQRS? Separation of consents. The command query independence can result in more maintainable and scalable models. Flexibility. Querying operations can be simplified by using different storage mechanisms for writing and reading. Performance. Reading operations can be optimized for querying data. The write side can guarantee consistency and transactional behavior. And the drawbacks. Eventual consistency. The use of CQRS can cause system inconsistencies by dividing the read and write sides, which may lead to stale data. Complexity. Separating commands and queries can lead to application design complexity, especially when integrating queues, publisher-subscriber events, asynchronous communication, and event sourcing.
If you want to learn more, don't forget to subscribe. May the code be with you.